Hello friends, we are going to start a new topic today, and that topic is very interesting, and it doesn't require any knowledge of mathematics as such. It just requires one very uncommon thing that I find among human beings, and that is called common sense, right? This chapter is based on pure common sense. What are you going to learn in this chapter? This chapter tells us how to count. Now you will be laughing, sir. We have learned counting since our standard one. No. You do not know how to count, and that counting principles is the basis of this particular chapter. And you will come to know that there are many things that you cannot count, and how to count things up. That is what we are going to learn here. So this chapter is the beginning of a science called combinatorics. And the chapter's name in your syllabus is called permutations and combinations, right? Permutations and combinations. Eventually, I will introduce you to both the concepts of permutation and combination. But right now, we'll learn some fundamental principles of counting. Okay? So let us start with fundamental principles of counting. Let us take an example. Suppose there is a town A here. This is a town A, right? And there is a town B here. Town B. And there is a third town. So there are three towns, A, B, and C. Now, I want to travel from A to C, and there are routes available. From A, there is a road connecting the two. There is a road connecting the two, and there is a railway line connecting the two. So here there is a railway line. Rail. Now, from the town B to town C, there are three routes available. One is again road. The second is you can travel by rail. And the third is you can travel by air. Now, unfortunately, there is no direct link between A and C. I want to travel from this A, this is my starting point, and this is my destination, right? Now, in order to travel from A to C, I have to take the intermediate station called B, intermediate town called B. Now, the question is, first of all, how many ways can I complete my journey? How many different ways of completing my journey? That is the question. So, these kind of questions we are going to solve in this particular chapter. So, let us see. From A to B, and from B to C, right? Now, you have to complete the job of traveling from A to C, but in order to complete the job of A to C, we have to first of all take an intermediate step called A to B and B to C. Now, you can travel by road or by rail. Either you can travel by road or rail. Okay. Now, here there is road, then there is rail, and one more option, air. So, first of all, suppose I complete my first task by road and second also by road. So, road. So, that means RR. Okay. So, that is my first option. Then, first I travel by road and then by rail, right? So, that means road and rail. Road and rail. Or I can complete the first journey by road and then by air. So, it is road and air. That is, so all options are exhausted if I travel by road from A to B. Now, suppose I decide to travel by rail. Okay, fine. So, rail, I will again go to road, correct? So, this will be rail, road. Rail, road. Second option, as you must have realized, is rail, rail. So, it is rail, rail. And the third option is rail and air. Okay, so it is road, rail and air. So you can see now, if you count 1, 2, 3, 4, 5, 6, there are 6 options of completing this journey. Now this answer could have been obtained by simply multiplying the total number of ways of traveling from A to B. There are 2 ways of traveling from A to B, and there are 3 ways of traveling from B to C. So if I want to travel from A to C, I have to complete these 2 things, 2 jobs. So there is a job number 1, traveling from A to B. How many ways it can be done? 2 ways. Job B to C, how many ways it can be done? 3 ways. So the total number of ways in which both the jobs can be completed together is 6. So you just have to multiply the 2 things and you get the answer. Correct? So this is how the first principle. So this principle can be generalized like this, that if there is a job A which can be completed in 3 ways, and if there is a job B which can be completed in 2 ways, and if I want to do both the jobs simultaneously, then total number of ways of doing it is just multiply the 2 things, 2 multiplied by 3. Now this gives me a general principle and first fundamental principle of counting. Okay, so let us take the first fundamental principle of counting. Okay, so let us derive now the first fundamental principle of counting. That is called, obviously it is called multiplication principle. Okay, now it can be described like this. If job A can be performed, if job A can be performed in m number of ways, right, and job B can be performed in n number of ways, then both the jobs A and B can be performed in m multiplied by n ways. See, both the jobs, here the important word is and, and. So that means I have to do both the jobs simultaneously, correct? So if I want to do both the jobs simultaneously, then it can be multiplication principle, okay? So this is the first fundamental principle called multiplication principle. There are several ways. I will give you one more example so that my idea will be very, very clear to you, okay? So for example, let us take a very famous obsession of all Indians, that is cricket, okay? So let us assume that there are 11 players in a team. So in a cricket team, as usual, there are 11 players. 11 players. Okay? And it's an Indian team, most powerful. So everybody can become captain, has got a ability to become captain. So, and everybody can become captain or vice captain. So suppose assuming that, okay? So I want to select how many ways we can select a captain and a vice captain for the team. That's the question. Assuming that everybody is capable of becoming captain, so we have got how many alternatives? There are 11 members and anybody can become captain. So job A, what is job A? Job A. What is job A? Selecting a captain. Selecting a captain, right? How many of alternatives you have for selecting captain? 11. So there are 11 members available for selecting a captain. Now there is job B. Job B is what? Selecting a vice captain. how many alternatives you have for selecting vice captain? Obviously, the one person who has been selected a captain is not eligible for becoming vice captain. You cannot have same person as captain and vice captain. These two persons are mutually exclusive. That is important. So one person is gone as a captain. So how many persons are left? Alternatives are left 10. Correct? So there are 11 choices for captaincy and there are 10 choices for vice captaincy. So therefore, according to multiplication principle, there are 11 multiplied by 10. So therefore, the total alternatives are 110. Correct? So there are 110 because if you take A as a captain, for example, A1 is a captain, then A2 can be vice captain, A3 can be vice captain, like that. There will be A11 can be vice captain. So with A1, there will be exactly 10 pairs. Correct? With A2, there will be exactly 10 pairs. Like that. There are 11 captains, therefore 10 plus 10 plus 10 plus 10 11 times will give you 110. Suppose A1 is a captain. So A1 is a captain. A2, A3, like that. There are 11 captains. Okay. With A1, there are 10 vice captains. With A2, there are 10 vice captains. With A3, there are 10 vice captains. With A11, also there are 10 vice captains. If you add all of them, then you will be adding 10 11 times. That is as good as multiplying 11 by 10, right? So that is how this job can be completed. Okay. Now, I'm going to ask you a next question based on the same theme. So there are 11 members, of a cricket team. Now, I want to select not only a captain and vice captain, but also a wicket keeper. So how many ways I have to do now? Now, in this case, there is a job C also. What is the job C? Selecting a wicket keeper. Now, this is a tricky question. Generally, whenever I ask these questions to the students, they make a mistake of writing 11, 10 and 9. That is a great mistake because you have seen wicketkeeper being a captain. You have seen wicketkeeper being a vice captain also. So for wicket keeping, all are eligible. So again for wicketkeeper, there are all 11 choices are there. Now you have to do 3 jobs. Job A can be done in 11 ways. Job B can be done in 10 ways. Job C can be done in again 11 ways. Therefore, the total number of ways of doing this job will be what? 11 into 11 is 121. So it is 121, 0. 1210. These many ways you can select a captain, vice captain, and wicket keeper is a very daunting task. Out of all these combinations, which is the best when I choose? So you can understand the difficulty of the selection team. Okay. Unfortunately, fortunately for them, there are not many who are eligible for all the 3 posts. So the job becomes easier for them. Okay, fine. So this gives you an illustration of the first principle of counting, that is called multiplication principle, which is very simple. I repeat again. Job A can be done in M ways. Job B can be done in N ways. Then both the jobs can be done simultaneously in M multiplied by N ways. Correct? So this is called counting principle number 1, fundamental principle of counting. Now let us see another principle, that is called second principle of counting, called addition principle. The crucial word, as I said in the last counting principle, was job A and job B. But suppose I don't want to do both the jobs simultaneously. I want to do the jobs either A or B. Correct? So the job A or job B can be done in M plus N ways. Remember, here the word that I'm using is or, and there I had used the word job and. So if there are 2 jobs, job A which can be done in m ways, and job B, which can be done in n ways, then either A or B can be done in m plus n ways. That is very simple. In other words, suppose there is a class A, class A, and there is a class B, division B, let us call it. So there is a class A division, there is a class B division. Class A has, let us say, 4 students and class B has 5 students. Okay. And if I ask you, go and select at least just one student either from class A or from class B. So either from class A or from class B. So you'll go to class A and you can select any one of the 4, or you will go to class B and you'll select any one of the 5. So total number of alternatives you have is 4 plus 5, provided the 2 jobs are connected with each other by the word or. So whenever there is a word or between the 2 jobs, A or B, then addition. But if I say, go and select one boy from each class, that means you will have to do both the jobs simultaneously. In that case, the alternatives will be multiplication principle, 4 into 5, then you will have 20 pairs. For every student that you are selecting from here, there are 5 alternatives here. So second student you select, again 5. Third select, again 5. Fourth select, again 5. So 5 plus 5 plus 5, how many times? 4 times. So therefore 4 into 5. So students, I want you to understand these 2 principles very correctly. There is a job A, can be done in m ways. There is a job B, can be done in n ways, right? If I want to do both the jobs simultaneously, I will multiply. And if I want to do only one of them, either of the 2 of them, then I'll add them, right?